All right, let's look at V3 negative exponents. So we're told, write the expression as a whole number with a negative exponent. Do not evaluate the expression. In other words, we're just writing it, leaving it as it is once we've turned it into a negative exponent. So we have 1 over 67 to the 99th power. In order for us to have a negative power, we have to place our exponent in the opposite position. So I'm going to move the 67 to the 99th power to the numerator. And when I do that, what happens is I end up with 67 to the negative 99th power over 1. So you could say you flip it, but it's not necessary to write it over 1. I can simply leave it as 67 to the negative 99th power. Let's look at 2. Which is equal to 22 to the negative 3rd power? Well, if we look at the first one, these are not equivalent, because if I take 22 to the negative 3rd power, then what I'm really saying is this is equal to 22 to the negative 3rd power over 1. And when I flip them, it becomes 1 over 22 to the positive 3rd power. So this would be the correct answer. This would be incorrect because it's not in the right position. This would be incorrect also because it's not in the right position. And this is completely different from what we have here. Write the expression as a fraction with a positive exponent. Do not evaluate the expression. So we've got number 3 is 67 to the negative 9th. You can place it over 1. You're going to flip it over. So you end up with 1 over 67 to the 9th power. Number 4, which is equal to 1 over 46 to the 5th power? Well, this would not be correct because although it's switched over, we don't have a negative base. What we have is a positive base. So let's go ahead and figure out an answer first and then we'll compare. So if I switch these over, I would have 46 to the negative 5th power. And remember, we don't have to write it over 1. Okay, so here the base is negative, so that doesn't match. Here the base is negative. It's in the same position though, so that doesn't match. 46 to the negative 5th power is exactly what we got. And this is incorrect because all they did was make the 5 negative, or the power negative. Write the expression as a fraction with a positive exponent. Do not evaluate. So number 5, we have 12 to the negative 98. We can write that over 1. If it'll help you to remember, you're going to flip this over. So it's 1 over 12 to the 98th power. Number 6, which is equal to 1 over 93 to the 879th power. Remember to flip them over. That's going to give us one of our answers anyway, 93 to the negative 879th power. So here again, this wouldn't be the correct answer because they made the base negative instead of the exponent. Here is not the correct answer because they made the exponent negative but left it in the same position. This one is not correct because they made the base and the exponent negative. That doesn't work. So our correct answer would be 93 raised to the negative 879th power. Number 7, we are asked to write the expression as a fraction with a positive exponent. We're told do not evaluate the expression. So 77 to the negative 119. Write that over 1. Flip it over. So we've got 1 over 77 to the 19th power. number 8, which is equal to 1 over 44 to the 89th power. Let me just go ahead and flip these over, and I've got 44 to the negative 89th power. Well, this is almost correct, but they made the base negative. That's not what we're supposed to do. This one's incorrect because it's in the same position and both the base and the exponent were made negative. This one is incorrect because the base was made negative and the exponent was not. This is the only correct choice. Evaluate, meaning we should come up with one single answer. Write your fraction as Write your answer as a fraction or a whole number without exponents. So when we have 2 raised to the negative 1, we know we can't have a negative exponent. So because this is raised to the negative power, we know what we have to do is make it positive. The only way to do that, again, is to flip it over. So I've got 1 over 2 to the first power. So since it says write your answer as a fraction or a whole number without exponents, 1 over 2 to the first power is simply 1/2. So now we've got 2 to the negative 2nd power. We know we can't do that. We have to make the exponent positive first. So we've got 2 to the 2nd power, or 1 over 2 to the 2nd power. When we evaluate that, we get 1. 2 to the 2nd power is 4, so it'd be 1 over 4. Let's look at 11. 3 to the negative 3rd power. Can't have that, so we switch places. It's going to become 1 over 3 to the 3rd power, and we know that that would be 1 over 27. 12 would be 2 to the negative 4. Again, flip it over, so we have 1 over 2 to the 4th, which is equal to 1. 2 to the 4th is 16. Thirteen is 8 to the negative 1. We flip that over, it becomes 1 to the 8 to the 1st power. Evaluate that. 8 to the 1st power is simply 8, so we have 1 over 8. 14, let's see if I can scoot a few more in here. 14 would be 8 to the negative 2nd power. Flip it over, so we've got 8 to the 2nd power, and that gives us 1 over 64. We have 15 here. 3 to the negative 2nd power is equal to 1 over 3 to the 2nd power. So that's 1 over 9. And one last one. Let's do 16. 9 to the negative 2nd power. We know that is 1 over 9 to the 2nd power, which gives us 1 over 81. I trust this was helpful for you. You know what? I'm going to go ahead and do this one because we're at 85. You might as well try to go to 90. At least you should. Or 100 would be even better. But I don't want this to stop you from doing that. So let's think about what we have here. We've got 1 over 2 to the negative 4th power. Well, remember, in order to make something, the exponent positive, we have to flip the base over. So here I would say, okay, 2 over 1 to the 4th power. So I just flipped the A and the B, and then I made the exponent positive. So 2 to the 4th power is 16. So our answer would be 16. And this is in your notes as well. So go ahead, take a look at those. Make sure you use your notes while you're completing this. If you have any questions, please ask. I'll talk to you later. Bye-bye.